My dear learners over there, I once welcome you again to our learning hub. We are taking on our lesson 14, that's math A. So in today's lesson we are going to look at total surface area. So we are now going to look at total surface area. So in the previous classes, in earlier classes, we've been looking at area, whereby we said area means the surface an object is occupying, so the amount of size or the space an object is occupying just on a plane like this. Then from in various classes we looked at areas of different figures or shapes, like the triangle, the square, rectangle, parallelogram, and so on. So here we are going to look at what we call the total surface area. So when you're looking at this total surface area, we are going to look at basically one, what we call a cuboid, and two, we are going to look at the total surface area of a cube. So in this video we are going to start with what we call a cuboid. So when we look at a cuboid is drawn. There are two various ways of drawing a cuboid. I can draw it in this way, like this one, and then I bring this one here, then here I make it dotted from this corner, then here, then when they meet, then I take it like that. So now to those who don't know how to draw this one, we can draw it in this format, like this one. So you start with that one, then you make another rectangle like this, then you join the vertices, this one to this, then here, then this one to this, and this to that. So this one makes what we call a cuboid. So we are now going to look at a cuboid. Then we are going to start with what we call the vertices. So how many vertices has a cuboid? So vertices are these sharp corners. We have this one, 1, then 2, then 3, 4, 5, 6, 7, and 8. So a cuboid has 8 vertices, so there are 8. Then we look at the vertices, then we are going to look at the edges. Then these lines are the edges. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So it has 12 edges. Then when it comes to faces, let me draw here another cuboid. Then we get the faces. So we have this one, then another rectangle like this, then we join this one onto this, then here, then this one with this one, then this one with this. Now when we look at this cuboid, we are going to look at now the faces. So how many faces has a cuboid? So we have this top part here matching with this one down, so this is 1, then we have this one down 2, then this one inside 3, with this side 4, then the other back there 5, then this front here 6. So a cuboid has 6 faces. Then examples of the materials with a cuboidal shape, we have the matchboxes. So if you look at that matchbox, a matchbox is a cuboid. We look at the boxes, these boxes that carry or that contain materials you buy at home, like the biscuits, then like the boxes of chalk, all those ones, they have what we call a cuboidal shape. So today we've looked at this one, then we will say it has vertices, they are 8 in number, edges they are 12 in number, and the faces they are also 6 in number. So in this lesson we are going to deal with the faces. So mainly here we are going to discuss the faces. We've said there are 6 there are 6 faces. If we try to draw this here, so we have this and this, then we are going to name the sides of this cuboid. So this joins with to this one, then this one with this, then here with this one, then this one comes with this. Now when we look at this one, so this side here is what we are going to call the length, then this side other side, or this one, is what we are going to call the width. Now this upper part is what we call the height. Now we are going to pair up these faces. We are having this base, this base is matching, it is length, width, matching with this upper base here, which is length and width. Are we getting that? So meaning that we have two faces, two faces, their length and width, the bottom. Then again we have another one which is length, width, the base. Then from there we have the side faces. These are two. Then we have the side faces. The side faces, they are width, height. Then this one height, and width. So they are to this one, width, height, they are also 2. So we have this one, which is width, height, then also another one which is width and height. Then we have the back faces. So we have this one here, this front face here, which is length and height. So we are having that one, and they are also 2. So this one and the back, the behind one, so it is length and height. Then another one is also length and height. So these are 6 faces, but they are in a pair. Now when we come back to what we are going to look at today, that is the total surface area, it means that total means we are going to add all the areas then where this cuboid is sitting, then we come up with what we call total surface area. Now when we look at this one, how do we get the area? So you have this one, area is obtained by length times what? Width. Then we also, there are 2, then we have length times what? Width. Then when you come to these faces, it will be width times height. Then this one will be width times height. Then when you come to this one, it will be length times height. Then this one will also be length times what? Height. But because we are dealing with total surface area, we are going now to add the areas of all these faces, that is length times width plus length times width, then plus length times height, plus then length times what? Height, then plus width times height, plus width times what? Height. Now from algebra, when we look at this one, this is how many LW do we have? We have 2 length times what? Width. Then plus how many these ones do we have? We have 2 length times what? Height. Then plus how many do we have? We have 2 width times what? Height. Therefore, from this we are going to formulate our formula, which is going now to be for total surface area of a cuboid is 2 into length width, then plus 2 into length times height, then plus 2 into width times what? Height. Therefore, that one marks the total surface, makes the formula for finding the total surface area of a what? Of a cuboid. I'm writing it here once again. So in brief, total surface area is TSA of a cuboid is equal to 2 into length times width, then plus 2 into length times height, then plus 2 into width times what? Times height. So this is the formula for finding the total surface area for a cuboid. Okay, let us go into some examples and see how we can go about this. So find the total surface area. Find the total surface area of the following cuboids. Of the following cuboids. So we have this cuboid here like this, and then they are going to give us the dimensions. So here now this one they are giving us 10 meters, then this is 12 meters, and now this is 8 meters. So they are telling us to find the surface area. So what you have to do in mind, at first what you have to bear in mind, that is to write the formula, that is TSA of a cuboid is equal to 2 into length times width, then plus 2 into length times height, then plus 2 into width times what? Times height. Then we are going to substitute in what is our length. Our length is now 10 meters. So 10 meters times the width, what is that one? The 12 meters. Then plus plus 2 into our length times height. What is the length here? It is 10 meters. Then what is the width? The height. The height is 80 meters. Then plus 2 into width times height. What is the width? The width is 12 meters. Then what is the height? The height is 80 meters. So let us now operate this. So this is 2 into, we are multiplying 10 times 12, that is 120 meters. Then plus 2 into 10 times 8. 10 times 8, what is that one? That is 80 meters squared. Sorry, here squared. Then plus 2 into 12 times 8. So we can multiply from here 12 by 8. This is 6. That is 16. Then we put here, then 8 times 1, 8 plus this one, 9. So this one is making up 96 centimeters square. Then after that we open the brackets. 2 times 120, that is 240 meters squared, then plus 2 times 80, what's that one? It is 160 meters squared, then plus 2 times 96, so we multiply it from here. Then 2 times 6, that is 12. You take this one to next place value. 2 times 9, that's 18, plus this one, that is this is 18, 19. So this is giving us 192 meters squared. So TSA, total surface area. Now we are going to add all these areas that we have obtained from the 6 faces of a cuboid. That is 240 meters squared, and then plus 160, then plus 192. So 0 plus 0 plus 2, this is a 2. 4 plus 6, that is 10, plus 9, that is 19. We take this one here. Then this is 1, 3, 4, 5. So the total surface area of this cuboid stands out to be 592 meters squared. Okay, so let us get another example here. So it is this. So let us get this cuboid here like this. So we are having this one like this. So we join this one to this, then this one here, then this one to this one, then we get this one here. So let us make our height to be 10 meters, then we make our width to be 20 meters, and our length to be 60 meters. Alright, so we are getting the total surface area. The formula: 2 length width, then plus 2 length times height, then plus 2 width times what? Times height. Okay, so we are having 2. What is the length? Our length is 6 meters, then times the width, what is that one? 20 meters, then plus 2 into what is our length? Our length, it is 6 meters, then the height, it is 10 meters, then plus 2 into what is the width? The width is 20 meters, then what is the height? The height is 10 meters. Okay, so from here we are now going to multiply 2 into what? 6 times 20, that is 120 meters squared, then plus, then plus 2 into what is 6 times 10, that is 60 meters squared, then plus 2 into 20 times 10, that is 200 meters squared. So we open up now the brackets. That 2 times this 120, that is 240 meters squared, then plus 2 times 60, that is 120 meters squared, then plus 2 times 200, that is 400 meters squared. So total surface area, now we are going to get a sum. This is 240, 120, then 400 here, 0, this is 0, this is a 4, 6, now this is a 6, then this is 5, 6, 7. So we come up with 760 meters squared. So let us get another example here. One more example. So find the surface area of this cuboid here. The cuboid here, then okay, with this one, then this vertex with this one, this vertex with this one, then this one. Alright, so here we are having 2 centimeters, then here we are having 5 centimeters, and here we are having 7 centimeters. Now when you look at this one, you have to identify the sides. This is the width, this is the length, then this is the what? The height. Then after identifying the sides, then we write our formula here. So it is 2 into L times width, then plus 2 into L times height, then plus 2 into width times what? Times height. Then from there we substitute in 2. What is the length? It is 2 centimeters. What is the width? 7 centimeters, then plus 2. What is the length? 2 centimeters. What is the width there? So the height, it is 5 centimeters. Then plus what is the width there? the width is 7 centimeters. What is the height? The height is 5 centimeters. So 2 into 14 centimeters squared, then plus 2. 2 times 5, that is 10 centimeters squared, then plus 2 into 7 times 5, that is 35 centimeters squared. Then from there we open up the brackets. 2 times 14, that is 28 centimeters squared, then plus 2 times this one, that is 20 centimeters squared, then plus 2 times that 5, that is 75 centimeters squared. So we are going to add up this one. So our surface area is going to be 28 plus 20 plus 75. Now that is 8, 9, 10, 11, 12, 13. Then here this is going to be 7, 8, 9, 10, 11, and 12. So it's going to be 123 centimeters squared. Okay, so with those 3 examples, let us now go in for the exercise, the activity. So please try to send this activity as soon as you finish doing it. Okay, number 1, the instructions are: find the total surface area of the following cuboids. 1, we are having this cuboid here like this one here. We join up with this one, with this. Then here we have 100 meters, then this is 20 meters, here we have 30 meters. Cuboid number 2, so try to draw neat cuboids as I've showed you. Then here this is 11 meters, we take this one as 10 meters, then this is 13 meters. Then 3 here, so we take this one here, then with this take this one, then this one here. Now this is 2.3 meters, then this is going to be 4 meters, this is 1.5 meters. Then number 4, let us take this cuboid like this here, then it joins here. Now let us take this one as 30 meters, let's this one be 40 meters, and this is 60 meters, 60 meters. Number 5, this one, let it be 23 centimeters, 40 centimeters, and 18 centimeters. This is number 5. Then number 6, -hmm. 11 centimeters, 16 centimeters, 15 centimeters. Number 7, let this one be 25 centimeters, 50 centimeters, and this is 60 centimeters. Number 8, -hmm. 11 meters, 16 meters, and 14 meters. Number 9, 9 here. So here we take 2.5 meters, 3.5 meters, 4.5 meters. Number 10. This one here. This is 200 centimeters, 100 centimeters, and 2 meters. Now when you look at this one, when you have different units, you have to convert them. So you will have to convert centimeters to meters, then you compute. Number 11. 800 centimeters, 700 centimeters, 5 meters. Still the same. Number 12. This is 900 centimeters, 120. Then this is 10 meters. So you've been a good learner, so please remember to send in your work for checking as early as possible. So we meet in the next lesson.